Most systems don't fail during experimentation. They fail the moment they scale. If you are looking for shortcuts, prompt hacks, or tactical tricks, this channel is not for you. Here, we design systems that must survive production, withstand audit, and operate predictably at scale. Welcome to Context Engineering Mastery. In Episode 2, we addressed cost. We demonstrated that intelligence can be economically constrained. Today, cost is no longer the primary threat. Unpredictability is. A system that performs correctly most of the time is not an asset at scale. It is a source of operational risk. What worked as a crafted solution at low volume becomes fragile when exposed to real users, real variability, and real accountability. This is the transition point. The moment where teams must stop operating as artisans and start operating as industrialists. SCALE is not a technology stack. It is a management doctrine for reliability. The acronym stands for standardization, consistency, adversarial controls, logging, and evolution. Each element exists to solve a non-technical problem: variance, exposure, accountability, and long-term drift. At scale, intelligence without discipline is not advanced. It is dangerous. The first phase addresses variance. If identical requests can produce structurally different outputs, the system cannot be governed. Standardization enforces a contract. The pipeline does not request free-form responses. It enforces predefined structures. Outputs that violate the contract are rejected automatically. This is not optimization, it is quality control. Phase 2. Adversarial guardrails, the shield. Once structure is enforced, exposure becomes the next risk. Unfiltered outputs can damage trust faster than they create value. Adversarial controls introduce a checkpoint. Every response passes through a supervisory layer before external release. This layer evaluates policy alignment, safety boundaries, and relevance. Responses outside tolerance never reach the user. The final phase addresses stagnation. A system that cannot observe itself cannot improve responsibly. Logging creates an audit trail. Every request, every output, every correction is recorded as operational evidence. Over time, these records reveal drift, failure patterns, and correction signals. Evolution becomes deliberate, not accidental. If you cannot explain why a decision was produced, it should not be deployed. Industrial systems require traceability. Without explanation, there is no accountability. Without accountability, there is no governance. SCALE exists to ensure every output can be justified, audited, and, if necessary, rejected. Models are interchangeable. Logs are not. Long-term defensibility does not come from the model provider. It comes from proprietary operational data, decisions, corrections, and failure responses accumulated over time. This data compounds. It lowers risk, stabilizes margins, and accelerates future decisions. 3 hard truths. Standardization enables control. Control enables scale. Scale without governance creates risk. Once reliability is enforced, a new question emerges. How much autonomy can this system be granted without losing control? That is the subject of the next episode. If this was useful, it was not by accident. I'll see you in the next episode.